Rohini College of Engineering and Technology from Department of Civil Engineering. So this is our final year civil engineering subject, 7th semester. So our subject title is CE 8703 Structural Design and Drawing. I'm Michael Devadurai, Assistant Professor. So now we can see about the flat slab and bridges. Design of reinforced concrete solid slab bridge. So example, design and draw the RC solid slab. So RC means reinforced concrete solid slab bridge for a national highway with consideration of following data. So design for two-way lane. Two-way lane means 7.5 meter wide and with 1 meter footpath on both sides. So clear span is equal to 5 meter and bearing coat is equal to 70 mm. Then width of the bearing is 0.4 meter. Use M25 grade concrete and Fe415 grade steel and loading IRC class AA tracked vehicle. So IRC means Indian Road Concrete class as based on all the values are taken from our IRC code books. So given data, 2 lane is equal to 7.5 meter, then clear span is equal to 5 meter, then bearing code is equal to 70 mm. So width of the bearing is equal to 0.4 meter. Then step number 1, determination of slab depth and effective span. So for permissible stress, it will be taken from our IRC 21 1987 class number 303.1. So sigma CB is equal to 8.3 Newton per mm square. Then sigma ST is equal to 200 Newton per mm square. Then M is equal to 10. Then J is equal to 0.9. Then Q is equal to 1.1. All the values are taken from our code books. So assume thickness of solid slab highway bridge at 80 mm per meter of span. So we can assume the slab thickness is 80 mm. Then overall slab thickness is 80 into 5 because of 5 meter. So 80 into 5 is equal to 400 mm. Overall slab thickness is 400 mm. Then thickness of slab is 400 mm. Assume using 25 mm diameter rebar with cover slab of 25 mm. Okay. So FI depth is equal to 400 minus 25 divided by 2 because diameter by 2 minus cover slab is equal to, we got a FI depth small d 362.5 mm. So width of the bearing is equal to 400 mm. So effective span. So effective span, the effective span is because of two conditions. First one is the clear span plus effective depth or center to center distance for bearing. So take the least value, finding out the effective span. So first of all, the clear span plus effective depth. So clear span is equal to 5 meter. Then effective depth is 0.36 meter. So for the first condition is 5.3625 meter, and the second one is the center to center distance. So 5 plus 0.4. So 5.4 meter. Take the least value. So the effective span is equal to 5.3625 meter. So see the diagram. So this is a bearing code. So this is slab thickness. Then two sides. To both sides are 1 meter footpath and 7.5 meter lanes. Lanes means roads. So step number 4, design dead load calculation. So self weight of slab is equal to 0.4 into 25. 0.4 means thickness of the slab. So 25 is the unit weight of concrete. So 10 kN per meter square. Then load due to wearing code. So wearing code is 0.07 into 22 is equal to 1.54 kN per meter square. Then bending total load is equal to 10 kN plus 1.54 is equal to 11.54 kN per meter square. So bending moments due to dead load. So based on dead load, our bending moment is WL square by 8. This is our formula. So we know that W value 11.54. L means effective depth value 5.3625 clear span value. Then divided by 8 is a constant. So got bending moment due to dead load is 41.5 kilonewton meter. Then step number 5, bending moments due to live load. So based on live load, first of all finding out the based on dead load. Now we have find out the based on live load. So impact factor is equal to 25 minus 15 by 4 into 5.3625 minus 5. Okay, so impact factor is 23%, 23.64%. So assume vehicle is placed symmetrically on the span. So in this span, we can assume that the vehicle is symmetrical. Okay, so effective depth of load is effective depth length plus 2 into thickness of slab, so 4.56 meter. So effective width of the slab is equal from IRC 21 1987 class number 305.13. So check the code book, these values are there. So see the diagram, this is the load, total load is the 43.21 kg meter square, our x is the 22.80 and full length is the 5362.5 mm. So B is equal to, this is a formula, Kx into 1 minus x by L by Bw, this is a formula. So x is equal to 2.681. Okay, so L is equal to full length 5.3625. Then B is equal to total width of the road, that including path values also. So it's 9.5 meter. So B by L is equal to B by L ratio is 1.77. So BW, so apply all the values in our BW. So BW is 0.85 plus 2 into 0.07 is equal to 0.99. Then K value for BL is 1.77 for simply supported is equal to 2.948. Or we can take it as a simply supported slab. KL value for B is equal to 1.77. Then B is equal to, apply all the values, you got it, B is equal to 3.913 meter. So see the diagram. So net effective width of the dispersion is equal to 6.36 meter. Then factored load with two tracks. Two track means two lanes. So 1.5 for factor load. The factor load is constant value is 1.5 multiplied by the load values. So you got it to 1298.22 kilonewton. Then average factor load is that load will be divided by based on length and say effective depth. So 4.56 into 6.31 is equal to 42.93 kN per meter square. The maximum bending moment for factor live load. So for factor live load, we will take on maximum bending moment. So load bending moment formula is WL by 2. So WL by 2. So apply all the all the values. So apply. Then maximum bending moment is equal to 150.85 kilonewton meter per meter. We can find out the per meters. Okay. So total bending moment is for dead load plus live load. So moment at live load plus moment at dead load. So moment at live load is the 150.85. Moment at dead load is the 41.5. So total moment is 192.35 kilonewton meter. So step number 6, shear force due to IRC class AA loading. The maximum shear force while acquires load subject towards the support. So the load will be based on the support. Effective depth of the dispersion. So we know the BE formula. So apply the same values in our BE formula. So you got the B is equal to width of the dispersion means BE. So B is equal to 3.825 meter. Then width of dispersion is equal to add all the BE values. So finally 6587.5 mm. So then take the average factor load. Average factor load is based on this. W is equal to 43.21 kN per meter square. Then factored shear force means, so based on effective depth. Then shear force, shear due to dead load, based on dead load means WL by 2. This is our formula. So WL by 2 means W is the 11.54, then L means effective depth 5.36, then divided by 2. So total shear force is, add the total values, 144.2 kilonewton per meter. Then step number 7, design of check slab. Check slab means effective depth required. This formula is a simple formula. Effective depth D is equal to root of M by QB. So M by QB, M is equal to moment. Then 150.85 into 10 power 6, 1.1 into 1000, the whole power 0.5 or root. So effective depth provided 400 mm, because 370.309 we can round it as taken as a 400 mm, hence it's okay. Then AST is equal to 2311.8 mm square. So find out the spacing also. The formula it will be same. AST YD square before B by AST. This is our formula. So assume 25 mm dia bars because this is a road construction, so we need to maximum reinforcement 25 or 32 you can take in that. Okay, so 25 mm, so D is equal to 25 mm, then B is equal to 1000 mm. Okay, we can assume that's the up to per meter, so B is equal to 1000 mm. So spacing is 212.33. So let's provide 25 mm dia bar. This spacing will be rounded as 220 mm. So provide 25 mm dia bar at 220 mm center to center distance spacing as main reinforcement, and 10 mm dia bar at 300 mm center to center distance at top on both sides. So bending moment for distribution reinforcement is equal to, we have one formula, 0.3 moment live load into 0.2 into moment of dead load. So apply the value. Bending moment of distribution reinforcement is 53.55 kilonewton meter. Then let's use 16 mm dia bars. So finding out the effective depth based on this. So you got the AST is the 870 mm square. Then finding out the spacing as well as same formula. So D is equal to 6 mm dia bar, spacing is 231.1 mm. So you can take 230 or 220 or 240, anything you can take. So provide 16 mm dia bar at 220 mm center to center distance at distribution reinforcement. Then step number 8, shear check. So maximum factored shear force V is equal to 144.2 kilonewton per meter. The nominal shear stress tau V is equal to VU by BD. So we know that load by area, the simple formula can be VU by BD. So VU is the 144 point our shear force, BD is the B is equal to 1000 and D is the 362.5. Then hence safe. Our tau C is the 0.4, tau V is the 0.39. So tau V is less than tau C. So hence safe. Then step number 9, check for development length at support. So M1 is equal to half into factor movement. So M1 is equal to 75.425 kilonewton meter. So development length for 25 mm dia bar at LD. LD means development length. So 56 into pi. This is our formula. Then another one formula is at 90 degree anchorage bend is L0, L0. L0 means anchorage length. So that is 8 into pi. So pi value is 25 meter. So 25 mm. So 8 into 25 is equal to 200 mm. Then LD is less than 1.3 moment of live load. So it will be VU plus anchorage length. So the pi is 15.7 greater than pi. Then we provide 25 mm diameter. So hence safe. So provide 25 mm dia bar of 50% of curtailment at 429 mm for support. Then step number 10, design of footpath. So finding the footpath, we know that width of the footpath is 1 meter, then depth of footpath is 0.6 meter, then dead load is equal to 0.6 meter into 1 into 24. 24 means unit weight of concrete. Then assume parallel parapet load railing. So 5 kilonewton per meter. We can assume 5 or 6 up to 8. Maximum 3 to 8 you can take as the parallel load parapet. So live load is equal to 3 into 1 is equal to 3 kilonewton per meter. Then total load is, add the total load, 22.4 kilonewton per meter. Then maximum factored bending moment. Maximum factored bending moment 1.5. Factor means 1 point multiplied by 1.5. WL square by 8 and 1.8. So it will be done in same step. Okay. So basically first you find out the bending moment, again you find out the factored bending moment, but in this step we can take as the same 1.5 also bending factored moment also. So bending moment due to vehicle load 0.6 into 150 is equal to 90.51. So total bending moment is, add the total load 211.3 kilonewton meter. Then effective depth is that 600 minus 25 plus 25 means cover slab, again 25 means diameter is equal to 562.5 mm. Then AS is equal to 2087 mm square. So provide 4 numbers of 25 mm dia bars at bottom and 4 numbers of 12 mm dia bars at top with 10 mm stirrups. We can provide a stirrups also here at spacing 300 mm center to center distance. You see the diagram. This is our solid slab bridge. It's a cross section of deck slab. So at the footpath area, provide four numbers are 25 in diameter. Then 70 mm varying coat we can provided. Then overall depth is a 600 mm. Then thickness of slab is the 4000 mm. Then 10 mm varying coat. Then 16 mm diabar at 220 mm center to center distance. Then 20 mm narrow print pad. Then 300 mm bed block we can provided based on their situations. Then 10 mm diameter at 300 mm center to center distance for slab.